Okay.
So what will be the polynomial?
The homogeneous the characteristic equation would be x, that should be squared, right?
Right.
Squared minus 5x plus 6.
Right.
Okay.
So what are the roots?
Mm, that is 1. Okay. 5 plus. No. Sorry. 5, 1. Um, 5. Um, 25. Yeah. Okay. X minus 6. So that is um, oh. Okay. So it is 3
Yes, one root is 3, another one is
and also 2.
right. So 5x you can write it as 3x minus 2x. So that's why. Right. So the roots are 2 and 3. So the general solution will be some constant 2 power n plus something 3 power n. Right. Yes. So 5 is not a root. So then using the, I think the first property, right? So it is not a root.
Mhm.
So what will happen?
It is not a root. Therefore, we can just say it is it just c times 5?
Yes, yes. So it will be just c
Okay.
times 5 power n.
Okay.
Right. So first, our aim is to find the c, right? So yes. So now we can just put it this particular solution into the given recurrence relation, right?
Um, see. S- Okay. Okay. It's actually great that you asked us to do this again. So how do you do that again?
Yes. So this one you just put it into, right? So here you have a n p minus 5 a n minus 1 p plus 6 a n minus 2 p. So that is equals to 5 power n. So now just using the things. So it is c times 5 power n minus 5c times 5 power n minus 1 n minus 2, right?
Okay.
So what we can take common from the three things?
Um, well, we have a0 is 1.
Yes, see, at least c is common in all of them. So c is common in all of them, and the highest power of 5
Okay.
that is
And
common is 5 n
this
minus 2,
5,
right?
5. Yeah.
So we
So
can take
C,
this one. If I take common, what is left inside?
um, should be 25
Right,
minus, that's okay, it is 25. So 25 minus 5. Wait. It's also 25. Yes.
right,
Plus that should be 1, right? So it's plus 6.
right, right. So what I have is, so that will cancel out these two things.
25c. Yeah. So also left hand and right hand side, the 5c 5 power n minus 2. That thing we can also.
Yes. So what I have is, so c is 25 by 6, right?
Mm, that is
Fine.
20. Okay. Yes. Yes. Yes.
So the particular solution what we got is it is 25 over 6 5 power n, right?
Mhm.
So now how to solve the homogeneous part? Okay, the initial condition I think they have given, right? So initial conditions are
A zero
a0,
is one.
yes, a0 is 0, a1 is 1. Yes, so now the general solution is nothing but the homogeneous part plus the particular solution. So homogeneous is a and b v2. Okay. So a 2 power n, b 3 power n plus 25 by 6 5 power n. Yes. So now how to find a and b?
Um. Well, we have two. I guess we can create two equations.
Yes.
So that system of equations will help us. So zero is a plus b plus 25/6,
Right.
and one is, yeah, uh,
Right.
yes.
I think
So
this part you can do. This part you can leave. Maybe later you can do. Just I'll write the solution from the book. So 2 power n has coefficient 22 by 3. So a is 22 by 3. And 3 power n has minus 23 by 2. So yes, that is fine. So this way, yes, this way we can solve it. But the idea is, so actually the idea is to learn how to use the generating function, because we have only limited type of functions which you can solve using this method, right? We can either solve it is a polynomial, or if it is a power of something exponential type of thing, right? Or a combination of both. If it is sine, cosine, or any other functions, so we don't know how to solve, right? Using the previous section. So then we have to use generating functions only. Only that is the way out, right? So that's why to get adjusted with the generating functions, they told to solve using generating function. So this part is clear. So I think there's just to recall the methods we followed this one. But anyway, so I think you have to learn the generating function also.
okay.
Yes. So see it quickly. So what is happening? So how to do it using generating function.
Um.
So yes,
So making that is making a n.
yes.
Is it just taking its Taylor series?
No, my generating functions is that is only, right. So what we are doing is, so we are actually trying to find the generating function of a n, right. So generating function of a n means I want a generating function whose coefficient of x power n is a n, right. So this generating function I want to find, right, where each of
Mhm.
the coefficient of the corresponding power gives me a1 a2 up to that one, right.
Mhm.
So we assume that ax is the generating function for the sequence a n. So that is what I mean by that, right?
I see. I see. I see. I see.
Generating function corresponding to sequence an means that one, right? So every xn will have coefficient an, right? So now using the recurrence, how to find the capital A of x? That is the generating function.
Um, you start from so I guess the idea is you want to be able to manipulate the function, the generating function, in a way that allows a few combinations of terms.
Right.
So for I'm
So this
looking at
is,
the book. So the thing is, for the first term, it's just ax,
yes,
a
yes,
capital Ax.
yes, yes. So
The
that is what
second
I wanted to
term,
say. So this is the recurrence relation, right? So I
mhm,
want to find a generating function such that this is the coefficient of x power n, right?
Okay.
A-
Mhm.
ax has coefficient an, but I want to find another generating function such that this becomes the coefficient of x power n.
Okay.
Right.
So
So how to do that?
if that's the case, um, sup- okay. Suppose we're looking at let's say x1 to x power 1, just
Okay.
x power 1. Then with the first with the first how should I say with the first term a n, so small a n,
Okay.
we have yes, in order to get yes, in order to get the thing you've written, we okay, okay, you know what, in that case, just write maybe a2 so starting from x
Yes.
squared, so a2 a2 a1 a0. Okay, that's much better. So to get that, we need to shift the second term by 1 and the third term by 2. And the way we shift that is I actually don't have this memorized, but I can always look at uh, uh, the, the formula itself and try it. So here we shift it by multiplying the whole thing by x. So not just by -5, but also by x.
Yes. Yes. So if you multiply by x, then the powers get shifted. It gets increased by one, right? So
Mhm.
an will have power x power n plus one, right? So that is the thing what is happening.
Yes, and then we shift the second
Yes. Yes, you tell. I'm just writing.
yes, the second um, thing is oh wait, shouldn't this be -5 a0x minus 5 ax squared? Oh, okay, okay, okay,
Yes.
okay. Yes. And then we have to shift. We have also to shift the last term to
Right.
the same to align with the previous two, and so multiply by 6. But this time we have to shift twice. So
Right. 6x square. So 6 a0 x square. Right. Right. So now we add all of them, right?
yes.
So if I add all of them,
Um, so we can add these together.
yes, then what will happen?
So for every, if I'm correct, so for every term,
Yes.
that is starting from, does it start from 2?
2 minutes.
As in, okay, so you can, so I guess what I mean by that is for each term,
Yes.
uh, so for each term x power n after n is 2 inclusive, uh, we can write its coefficient as uh, a a okay. You know what? Um, so if we add them together, we have a 0.
Okay, I think I understood. The thing is, what you're saying is, so the common term that is in every expression that starts from x square, because this is the term that will first combine.
Yes. What I mean, yes. So yes. So I starting from, so let I equals 2 I plus plus basically.
right? So if we add all of this, so then I have ax, then product with 1 minus
1
5x.
1 minus 5x plus 6. Yes, and
Yes.
also we have a0 plus a1x.
So these things are there. Then I'm
Mhm,
starting from I equals to 2 to infinity. This is ai minus 5 ai minus 1 and 6 ai minus 2 x power
mhm.
sorry x power I. Fine.
Yes.
Right. So now actually we can use our initial conditions. So a0 is 0 and a1 is 1. So that's why we have
Mhm.
fine. Up to this, I think it is fine, right?
Yes. Yes.
Right. Now what to do?
There should be a really. Oh yes, yes. This coefficient
Yes.
is always is it always evaluates to 5 power n.
Right. So that is now we are actually using the recurrence relation what they are given. So this is nothing, not 5 power n, 5 power I here because we are using I.
Oh. Yes, 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 yes. Right.
Right. So yes. So now do you know, means do we know this summation? So from I equals to 2 to infinity, 5 power I x power I. Or yes, we can write it as whole 5x power I. So this is actually that infinite GP series, GP sum, right? But the thing is, it is not starting from. The thing is, what we have is, so 1 plus x square up to infinity. If I have, I can write it as 1 by 1 minus x, right? But
Mhm.
actually, it is starting from 2, means it's starting from x square. So how to adjust that?
So we can just minus 1 minus x. Can we?
Yes, minus 1 minus x that we can do. Uh, yes, but also one thing what I can do is, so suppose it was starting from x square, right? X cube, then we can take out x square as a common, right? That we can also do, right? As if it takes x square, then
Oh, oh, yes. I forgot it's an infinite. Okay, okay. Yes. You can do that, of course. Yes.
right. So if I take this whole square outside, then it just translates to I to 0 to infinity 5x to the power I, right?
Hmm. And then we have this is basically 20 25. Okay, that's fine. That's fine. And then 1 minus 5x.
Right. So now just simplification. I think that the book we can copy what they are given.
Yes.
So x 1 minus 5x. Yes. So now what to do? So now I have ax times this thing is this quantity. So I can bring everything to one side and keep ax on the left hand side. So what I have is
I guess we it's probably a good idea to factor the
yes, yes,
1 minus
factorization. Yes,
before
factorization.
we bring it over. So
Yes, yes. So factorization we already know. So this is I think we did right. Tell me what is the factorization?
I don't think we did that, but we actually never learned how to factor. We just learned the basic the root equation. But I can use that anyway. So
Yes,
that's 5 um, plus or minus 25 minus. Okay, and a here is 6, so it's 12. So it should be 5 plus 5 okay. It's either 1 over 2 or 1 over 3. Is that correct?
yes, yes. Roots are either 1/2, 1/3. But the thing is, yes. So how to write it?
Um I guess we can write it as x minus. No, sorry. Uh, so x minus 1/2, but then we multiply. Can we?
Yes, I think what you are trying to do is, let me write it down. That will be easier. So I have 6x square minus 5x plus 1. So we can take 6 common, right? So because we are familiar with monic polynomial, that helps us, right? Right?
Hmm.
And this is 2 over 6 and 3 over 6, right? Something like this you are trying to do.
Oh, yes. I know the um um. Okay, so and then we have
So this is actually 1 over 3 and this is actually 1 over 2. So this gives you x minus half and x minus 1 by 3. Right?
mhm.
So now we can multiply this 6 inside to make it look like 2x minus 1 and 3x minus 1.
Yes, exactly.
Okay, so in the book, so this is actually same as 1 minus 2xn because we can take negative. So just to keep in line with the
Yes,
book,
because
what they have.
two negatives. It's just
Yes.
yeah.
So what I have is, yes. Now, yes. So now you have to actually find a series type of thing, right? So how to do from here? So do you know partial fractions?
I've never learned that by name, but I yes, I know what that means.
Yes. So tell how to do it after this.
Um, we are um, how should I say this? We are splitting it into because we started with three terms. We'd also split it into three fractions,
Yes. No, that
right?
is not the logic. The logic is because so we have to
Oh,
because the
because we
thing.
have three. How should I say? Three terms like this in the
Yes.
denominator.
Yes, that is fine. But actual logic is the thing is I know. So the expression of 1 by 1 minus s x. So this Taylor expansion or infinite series expansion I know. So that's why I want to do like that because as a whole, this
Oh,
expression I
okay.
don't know.
Oh, okay. I see.
So that is the reason. So the thing is, if I can express it as some constant time 1 minus 2x plus some constant times 1 minus 3x and 1 minus 5x, then individual terms I know how to expand using the infinite series. So I want to express like this.
I see.
So this is called the partial fraction. Right.
Mhm.
So now you
So,
know how to solve for B, C, D, and D.
we need three. We need three equations,
Yes.
right?
So how will you get?
We already um. I guess we can first multiply both sides by just to get away, just to get rid of the. Can we
Denominator.
do that?
Denominator. You're saying?
Yes.
Yes. That only you have to do. So what I have is, so yes, now I am just leaving out ax. I am just now comparing these two sides. So then I have 20x square plus x. So b into,
Hmm.
right?
Mhm.
So now we have to just multiply the whole thing and compare the coefficient of the like powers,
Mhm.
right? So that we can just
Yes.
take from
So
the book.
there's x equals 1 over half, 1 over 2 that we have.
Yes, yes. So the thing is, before that, the one easy one that they're doing is x equals to 0, right? That will give me one solution. So if I put x equals to 0, so the left hand side is 0 and right hand side is b plus c plus d.
Just to make sure, is this 0 chosen for its convenience, or there is a reason it can be
No,
chosen?
no, that is convenience. So we have to find three equations, three independent equations, right, to solve b, c, and d.
Okay, 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 okay.
So that's right. So next we are doing half. So if I took half, then two terms will become 0. So this will become 0, this will become 0. So only we'll left with b, right?
Then we have on the left hand side 5 plus half.
Okay, okay. I think in the book they have taken BCD in some different orientation, but that is fine.
No, 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 yeah, but 5 plus 2.
So this will leave us, right?
Mhm,
So this will give us B as 22 by 3. Fine.
mhm.
And then if I take 1 by 3,
With 3, then we have on the left hand side 29. It's not actually easy to compare. So
yes, anyway, that C will become then minus 23 by 2. Right? That is our C. And then now putting them into this equation, B and C, we can find D. So D is, I think, the other one, 25 by 6. Right?
mhm,
So now you can, so we have our equation, the generating function I have. So ax is your b divided by 1 minus 2x. So 22 by 3, 1 minus 2x. Then our c is minus 23 by 2, 1 minus 3x plus 1 minus 5x. Right?
mhm,
So now I know the expansion of each of them. So I equals to 0 to infinity 2x whole power I equals to 0 to infinity. Right?
mhm.
So if I take the summation common, so this is my solution. So AI is this one, or AN will be I replaced by N. So that is my solution. That is what same thing we got there also.
I see. I see. I see. I see. There is this. I guess actually, I looked at the. They turned this whole so that whole fraction into three. They broke it apart into three. I just thought, okay, because you needed three. I just say that you needed three. Uh,
Terms.
co- yes, you needed three terms. That's why I never thought it was because you wanted to know the because you knew how to do the generating function.
Yes, yes. Because actually, I what I find what is my aim. So the thing is, I want to find this AX, some summation AN power x power n. So I want to find this coefficient, right? So I want to find something, some way of expressing this into a infinite series. But this I don't know any formula, right? So the only way we can do is we will break it into this linear type of things, and then I have some idea how to do it because this expansion I know.
I see. I see. I see. I see.
So this is fine, I think. So next one is slightly more difficult. So because they are trying to solve the system, but the thing is, this system you will not be able to solve using the previous method. Means using the usual characteristic, because what you solved the system of equation you saw till now, you substituted one system into the other, right?
Hmm.
That way you solved in the previous section when you have a system, right? That's 6.6. But here actually you can see that you cannot substitute because there is a two-step recurrence relation, and you cannot isolate out one by substituting one in the other, right? If you see the example 6.7.3.
6.7
Next one,
point 3. Mm-hmm.
right?
Mm-hmm.
So this is our system 2a minus 1 plus 4b n minus 1. So in previous section what you saw is you can actually isolate the sequence, the system, by substituting one into the other and reducing the variable to single variable. But here actually you cannot do that. So how to solve it when you have such a system? So here also our generating function will help us do it. Yes, so that's why it is slightly difficult.
Um,
So this one have you seen before?
to be honest, I just assumed that you could just easily substitute, and this is just a somewhat more longer. So I didn't even pay a lot of attention to it.
Okay. Yes. So now you understand, right? You cannot substitute, right?
Yeah, that's not that's not possible here. So
Yes.
um, um, uh, maybe let's just write out two generating functions. Is that
Yes. Yes. So you have to find because two things you have to solve, right? So you need two generating functions. So that is clear. But how to use that? So yes, we can start with that. So ax be the generating function corresponding to the sequence an, and bx be corresponding to bn. Yes. Now.
um? We want to okay how okay this may take a few more tries, but I guess the idea is to construct again
Right.
um, a generating function such that we have the how to say all the three terms lining up for
Yes.
each for either function. So I guess what we can do is manipulate ax by shifting it by multiplying it by 2 and then shifting it to one place.
Yes. So 2x we need to do, right?
So yes, so 2x a ax.
So I'm just writing one because a0 is one they have given. So I'm just directly writing one. So that is our aim. Then 2x if you multiply,
Is a 2x.
it will become. So I'll writing below the corresponding
Mhm,
term so that it will become easy to see,
okay.
and so on. It
And,
will be
yes. And then we just directly shift multiply bx by 4 and then shift it one place.
right. So for bx will be
The first term is 0. So wait, do we have to shift it? Um,
yes, yes. First term is 0. So we have to start from the second term, but after shifting that becomes the third term, right?
Okay, so that is 0 plus 4. Okay, okay,
So it will be 4b1 x square. So it will start from here, and this will be 4bn minus 1 x power n. Right?
okay. So we have this whole big thing. Together we can.
4x bx. So this thing will have your 1 plus.
Uh, 1 plus
So I equals to
starting from x squared, right?
yes,
So
yes.
we still have to
So
write a1 plus 2x.
right, right. So we can take comma from here. So 2 to infinity.
Yes, and x power I.
No, so this is sorry. This is I minus 1
Oh yes, 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 yes.
x power I. Right.
Yes, and then we write the same thing. To be honest, at this point, can I just look at the wait? Does the book write it? Oh yes, yes, yes. The book just spit it out. Uh,
Yes, yes. So but these terms I know it is 0, right? Because that is the given. That is given in the system, right?
yes.
So what happens to a1? A0 I have 1. What is the value of a1?
A1 is 1, right? A1 is 1.
No.
Yes, A1 is 1.
How?
Sorry, sorry. Oh, sorry, no, 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 no. A1. Oh, A0 is 1. A1 we.
We have to compute from the first one. So from here, a1 plus 2 a0 plus 4b0 is 0. So
Oh, oh, okay.
so a1 plus 2 is also 0. So that's why this term will also vanish. Fine.
Okay, yes. So this whole thing is 1.
Right. So what we have is equals to 1. Yes. So one thing we got. Now we have to use the second recurrence. So the second recurrence is this one. Yes. Now tell me.
I'll just go from the book. Is that okay?
Yes. Yes.
So 1 it evaluates to 0. So 1 minus 6x times bx
Right.
uh minus 4x ax 0.
Right. So this is fine. So now this is my first equation and this is my second equation, right? So now here you can see that these are the variables. Ax, bx are variables. Now you have to just
Mhm,
solve this system as a usual system of equations.
mhm. Again, can I just go to the book?
Yes, yes.
The
But the thing
Yeah.
is, thing is you understood it, what I'm saying.
Yes, yes. So I guess solving that is very technical, but to know how to get these equations, that's another story. So.
Yes, yes, that is different. But the thing is, you have to just solve this as a thinking of this as a variable, right? So I think you
Mhm.
can do it later. So ax we are getting as 1 minus 6x and bx is right. Now I know. So this expansions at least I know, right? Means let us leave this one.
Yes.
So
So
one
so
over
we
this
can
thing I know, right?
that wait is that we okay we started from 2, right? I equals 2.
Okay, but
Or
yes,
did
yes,
we
tell.
start
Tell.
at
Okay, don't think about this one. So just tell me the general one. So 1 minus ax whole square. What will be the expansion?
That is let me check my notes. I
Yes,
have
yes.
it written down, but
I think we did this one from that when you are doing that commutative analysis book. I think this came. This we did.
yes, but the okay. Um, equals x 1. That is 2. So that is like 1. So so the first term is 1. The second term is 2a squared x. This is 2ax. Third term is
Mm,
3. Is that correct?
okay. So actually, I don't remember. So I can actually derive it. So the thing is, what we have is 1 by 1 minus ax. This one is clear to us, right?
Mhm.
So this one is summation. Okay, let me write down in the whole thing. So 1 plus ax square like this, right?
Oh, we just multiply it by okay.
No, no, no.
Do
Multiply
we?
it will be difficult, right? Yes. So what we can do? So if you derivative, take the derivative on both sides. So if I take the derivative on both sides, so it becomes whole square minus, right?
Mhm.
Minus a. So that is the chain rule, right? Tell me whether it is correct. I have to also check.
On the other side, we have a plus a squared
Yes.
x two a sorry two a squared x.
Mm,
Wait. We're differentiating with regard to x, right?
right, right. X with respect to x.
So yes, that should be a squared x, 2a squared x,
Right,
and then 3. Yes, 3a cubed x squared.
right.
3a cubed x squared.
Okay.
Is that
3a cubed x square. Yes, that is correct. And so on, right?
okay? Yes. So
But
we can
one
just
thing,
take
is this
out.
derivative correct from
Yes,
here
we
to
can
here?
just take out. Um.
From here to here, is the derivative correct? Because this one will become whole square, that is fine. Now, due to denominator, 1 minus will come. But again, due
Mhm,
to chain rule, minus a will come, right? So it will be minus
mhm.
1 into minus a, right?
Wait. Do you mean multiply? So two negative signs or one?
Yes, yes. Two negative signs will come, right?
Yes.
Right.
It's
So what I have is a divided by 1 minus ax whole square equals to this thing. So we can cancel 1a from both of the sides, right? So 1 divided by 1 minus ax whole square is nothing but 1 plus 2ax, 3ax whole square, and so on, right?
mhm,
So in summation terms, what we can write is, so I equals to 0 to infinity,
0
I plus 1, and you have
a x
right
ax power
ax power I,
I.
right?
Mhm.
Ax power I. Fine.
Yes.
So right. So now we can just substitute back here. We have a equals to 2. So what I have is, so ax is 1 minus 6s will be there as usual, and I have I equals to 0 to infinity I plus 1 to x power I, right?
Mhm.
Up to this is fine, right?
Let me just write down the whole. One sec.
Yes.
3x. Right. Okay.
Right.
Okay. Yep.
So now I think we can just find out the coefficients like this, right? So maybe this one will be easier for us first to find out. So I can take inside 4x, we can take inside. So I equals to 0 to infinity 4 I plus 1, and 2 power I also you can take out, and it is the coefficient of x power I plus 1, right?
Hmm.
So Bn will be nothing but 4 times n 2 power
N minus
n
1.
minus 1, right? So n times 2 power of n plus 1. So this is Bn, right? And from here an is slightly complicated, but that also you can do. Let me copy it. So here actually you have to break up the summation into two summations. So it is I equals to 0 to infinity. Okay. So this is 2 power I x power I, and minus I equals to 0 to infinity. If I take 6x inside, so I have I plus 1 2 power I, but it is the coefficient of I plus 1. So then an will be, tell me.
I and no, 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 it's not I. Sorry, sorry, it's not I. I and n plus 1
Hmm.
times 2 power n
Right,
minus 6 n, right? Not n plus 1, n,
right,
n,
n,
times 2 power n minus 1.
right. So from here I can take 1 2 inside, so it becomes 2 power n, and so 2 power n, if I common take common, then n plus 1 minus 3n. Right. So this is my an and this is my bn.
Mhm.
Fine.
Uh, yes, yes. The thing is, I think we have some, still have some time left for the Catalan. Maybe not entirely. Um, let's see. So, uh, we're on page. Okay. Uh, so page 260.
Yes.
There is this mention of AP. So both in capital letters, AP and MP.
Yes. So I think that is in the book they have mentioned in the first chapter or second chapter, as far as I remember. So something called arithmetic principle and multiplicative principle, something that is there. In the initial chapters you can see once. Exactly don't remember the page number, but I think in chapter one mostly, or chapter two maximum. So there is something called arithmetic principle and multiplicative principle while computing numbers. So they have given some principles.
I see. I see. I see.
So have you gone through this 6.8 section?
68. The Catalan number thing. Not. there are some questions, but I guess what I can do instead of always doing this in course, and so there are some things. So I guess what I can do is I'll try to write down on a piece of paper by hand
Yes.
my attempt at following the book,
Okay.
and then whenever I run into a problem, I mark it with a question mark and I send it to you before class, and so we can get it faster next time.
Yes. Yes. Sure.
That works fine. Um, I understand I guess the idea of oscillating. So I guess the easiest thing um, is, for example, negative one, one, negative one, one, that kind of stuff.
Yes. Yes.
The um, the examples they gave on page 263, I actually have to say that they're more confusing than helping, at least for me. I guess it's probably because I didn't read earlier chapters.
Yes. Some. Yes. That I will. We can discuss. That is fine. We can discuss. Wherever you have doubt, we can clear it. Okay. So next class we are having. We are